All right, so yesterday we looked at solving basic inequalities. Okay, things like 2x plus 4 is less than 5x minus 8. Right? The point is, when you solved it, all you had was an x. Okay, you didn't have anything with a higher exponent. Okay, today we're going to look at inequalities again, but we're going to look at ones that have exponents that are higher than just a 1. Okay, like quadratic. And maybe 1 cubic. All right, so we've seen this formula before. It's the one for projectile motion. Negative 16t squared plus v sub 0t plus s sub 0. Okay, so if you want to copy it down again, you can. And what this formula gives you is the height of an object based on a couple things. One is how fast you throw the object. That's your initial velocity. And how high you are when you throw the object. If you have a problem that says something about ground level, that's an initial height of 0. Any time units that you plug in have to be measured in seconds. Any distance units will come out in feet. And that's because of the number negative 16. That has to do with feet and seconds. Okay. Any question on the formula? Okay, so example 1. It says a ball is thrown straight up from ground level with an initial velocity excuse me, of 80 feet per second. Okay, so we know it's from ground level. Being thrown at 80 feet per second. Okay, I want to figure out when the ball is at least 64 feet above the ground. Okay, I try to keep the formula up so people could see it, but does everybody have the formula? Okay, now I can make it a little bigger. Now, what phrase in that sentence makes this problem an inequality? When is the ball at least 64 feet above the ground? Casey?
At least, because it's talking about the minimum and then beyond that.
Mm-hmm. So at least 64 feet means 64 feet or higher. Okay, that's a greater than or equal to 64 feet. All right, so it says to use the graphing calculator to figure that out. So let's write down what we're going to plug in first. Okay, we want our height, okay, of this object to be greater than or equal to 64 feet. So now we just need to fill in the formula for the height. Okay? So the height of the object is negative 16t squared plus v sub 0t. Caitlin, what's my initial velocity in this problem? Yep. So initial velocity plus my initial height. Matt, what's my initial height here? 0, right? From ground level. So I don't need to put plus 0. So that's my height. And I want to know when it's greater than or equal to 64. Okay, so the way we'll do it, it says graphically. So type what's on the left in y1. Type what's on the right in y2. Let's set our window. So x is the variable I have to use. I can't use t, but x represents time. Can time be negative? No. The maximum amount of time, that's how long the ball or whatever is in the air for. Okay, I don't know. I'll try 10 seconds. Can the object have negative height? No. But how high is the object going to go? At least we're hoping it goes how high? 64 feet. Might even go above that. Okay, so let's hope it doesn't go over 90 feet. Well, it goes over 90 feet, but for the moment, I'm not looking at how high it goes. I just want to know when the ball is above 64 feet. Okay, so what do you think I'm going to have to calculate between the blue curve and the red line? Yeah?
The intersects?
Yeah, I need two intersects. So you could pick any time value between, and now I need to find the two values. So I'm going to do intersect. Okay, I'm going to do the one on the right. If somebody else could do the one on the left while I'm doing this one, that'll be good. So the ending time is 4 seconds. After 4 seconds, the ball is back on its way down, and it's going to drop below 64 feet at 4 seconds. Does anybody have the other intersection point when it's on its way up? About Kelvin? Did you get that one? Did you type it in? Someone who has that typed in, can you tell me? Yeah?
It was 1.
1, thank you. Okay, so any time between 1 and 4 seconds, and the object is 64 feet above the ground. That's it. Any questions on that? So we just solved a quadratic inequality. It's quadratic because of the 2, using the calculator. How long does the ball stay in the air? Let's go back to the picture. Where on that graph do you think, looking at the blue curve, would tell you when the ball hits the ground? Because that's basically, when it hits the ground, at that time is exactly how long it was in the air for. Yep.
When it crosses the x-axis?
Yeah, where it crosses the x-axis. That point right there. All right? So let's see how we could do that. Let's do it algebraically. So we want to know when our height is what? If the object is still in the air, what's the height? It's at least above what number? It's still above 0. So I want to know when my height is above 0. So I'm going to take my formula for my height. Negative 16t squared plus 80t. And as long as that height is above 0, it's still in the air. Okay, any questions on that? Okay, so let's see if we can solve that. Does anybody see what I can factor out from the negative 16t squared and the 80t? Yep. Let's start with the number. That's a good place to start, but you can do an even bigger number.
16.
So we're going to do a 16. I'm also going to do a negative with it. Anything else they both have in common?
T.
The t. So let's factor that out. If you factor that out, you're left with t. And in the other part, minus 5. Any questions on that? Okay. So now we're multiplying two things together, and they have to be greater than 0. Well, t is time. What kind of value is time always going to be?
Second.
Yes, it's always going to be in seconds, but how about, yeah, that's what I was trying to get at. It's always going to be a positive number.
Greater than 0.
Always going to be greater than 0. So this, the t, is always positive. Now, if you plug in a number that's always positive times negative 16, what is this whole thing going to come out to?
Negative.
This thing is always going to be a negative. All right? Any questions on...
Mr. Cadudo?
Okay, so any questions on why what I just circled is always going to be negative? Because it's a positive times a negative. Now, look at the whole thing. A negative times a what would be greater than 0?
Negative.
This would also have to be negative. Because the first one is already negative. We can't control that. But if you want to get something greater than 0, you have to multiply a negative times a negative, and then it would come out greater than 0. So really, the question is just, when is t minus 5 negative? If you can answer that, it'll tell you when the object is above 0 height, which means it's still in the air. Right? So when is this negative? Because if that comes out negative, and then you multiply by another negative, then it's going to come out positive. The two negatives cancel. So how would I solve that? Add 5. That's how long it's in the air for. Less than 5 seconds. So technically it's in the air like 4.99999 seconds. When you hit 5 seconds, what happens? It's at 0, which means technically it's back on the ground. But if you said the ball is in the air 5 seconds, that would be okay. But technically it's just under 5 seconds. Okay. So, any questions on that? Now, the only reason we could solve that is because we were able to factor. Okay? All the inequalities that have higher exponents, like 2's in them, you have to be able to factor it. Okay? If you can't factor, we can't solve it the way I'm going to teach you today.
Can't you just look at the calculator though and see where it is in the x-axis, and I'll just give you 5, because that gives you.
If they want you to solve it graphically, that's perfectly fine. Yep. If they ask you to solve algebraically, then you'd have to show that. Yeah. So we do a mixture of both. This question I'm going to hold off on. It's the question we just answered graphically. I was going to do it algebraically, but I'm going to show you something first that will help you with that. Okay? And it's called a sign pattern. All right, and the idea of a sign pattern is that every linear factor, okay, a linear factor is something like 2x plus 1, x minus 7, okay, just an x, nothing squared, just something like this. It's like, think when you do factoring, that's a linear factor. There's one number you can plug in there that would make that 0. Okay, that's what I'm saying right here. What number would you plug in to make that 0? You plug in -3. So I'm just going to mark that on a number line. That's the dividing point between, if you plug in an x value, are you going to get a negative result or are you going to get a positive result?
So that's the 0.
That's the 0. What if you plug in a number smaller than -3 for x? What kind of answer would you get?
Positive.
Smaller than -3? Like -10. You get a negative. Now, what if you plug in something on the other side of -3? What? Yeah, if you plug in like.
-2 would be 1.
Yeah, if you plug in -2 plus 3, you get a positive 1. So -3 is kind of the dividing point between, if you plug in numbers on one side of it, you get negatives. If you plug in numbers on the other side of it, you get positives. If you plug in exactly -3, you don't get a negative or a positive. You get 0. So any questions on that idea? All right. This is kind of the same thing I just did up there, just with different factors. If you had t minus 1, the 0 would be 1. If you had t plus 4, the 0 would be -4. And for the first one, if you plug in numbers smaller than 1, you're going to get negatives. If you plug in numbers bigger than 1, you're going to get positives. Okay? That's the important idea. You have to figure out where things are negative and positive. So I kind of just did this up above. But once you figure out the root, you're going to mark that root on the number line, just like I did. Okay, mark the root, mark the 0, same thing. Once you put that on there, then you're going to determine the sign. What happens if you plug in numbers smaller than your 0? What happens if you plug in numbers bigger? Okay, usually one side is negative, and then on the other side it's positive. Okay, we're going to make probably like 5 or 6 of these, so we'll do a lot of them. Okay, and page 113 has some more pictures, but again, we're going to do plenty of pictures right now. Okay, so any questions on that? All right. So we'll start with a problem. Okay, leave a little bit of space under that because there's one more thing, probably about the same amount of space as that I'm going to have you write in. But we'll come back to it after let's just try to do up to that step. Okay, so in order to do this, your problem has to be factorable. If you can't factor it, you're not going to be able to find the linear factors. Okay? So let's see if we can factor it. Okay, anytime you solve a quadratic, I didn't mention it because we've done this before and you did it way back in Algebra 1. What number always has to be by itself when you're solving a quadratic on one side?
X.
What number? What? No, number. When you're solving a quadratic, you always get it equal to
0.
0. Okay? You always get 0 on one side. Okay. This problem is already set up to have, it's already got 0 by itself. So does the next one. Okay? All right, so now it's 0s on one side. Okay, we're ready to factor. Would have to be my first term in each set of parentheses. An x and a 2x. What about my signs? Both positive, both negative, one of each. One of each. Anytime your constant is negative, you need one of each. I would probably try it like this. If that doesn't work, you could always try switching it. And then 2 numbers that multiply to give me 5. 5 and 1, I'm going to do them in the other order. But I am going to use 1 and 5. Let's check it. 2x times 5 gives me 10x minus 1x, 9x. That's exactly what we wanted. Okay, so now we factored it. So let's start with 2x minus 1. Okay, what would be the 0 for 2x minus 1? What would you plug in for a half? What would you plug in for x so that it comes out to be 0? A half, yeah, I accidentally told you. So if you plug in a half for x, it would come out to be 0. Any question on how you figure that out? Because 2 times a half is 1. 1 take away 1 is 0. So x is a half. Now, what if you plug in numbers smaller than a half? Like, let's say you plug in, pick anything you want smaller than a half, negative 10. What kind of answer would you get? Just in the first factor. You would get a negative. Now, what if you plug in something bigger than a half, like 20? Yeah, if you plug in a number bigger than a half, you would get a positive result. Okay. Let's do the same thing again. What would you plug in for x there to make that 0? Negative 5. What if you plug in numbers to the left of negative 5? What would you get? What kind of answers would you get?
Negative.
Negative, like negative 10. If you plug in that, you get negative. How about to the right of negative 5?
Positive.
Yeah, like if you plug in 0, you'd get a positive result. Okay. Any questions on that one? Okay. Now, where I told you to leave a little space, we're going to take the individual number lines we just had, and we're going to combine them into one. Okay. I guess you could kind of do this as you go, so you don't have to do it as an extra step, but that might be confusing. So take the sign patterns you have for the individual and now combine them together into one. This particular problem is about a product. How do you know it's a product? It's something times something. We're going to do one that's a quotient after. That's a quotient. Okay, so combine your individual sign patterns into one. You could just write that. That's all you're really doing. Okay, so I'm going to draw a number line, and we're going to mark the roots, or mark the zeros.
-5.5.
What's that?
Like you do like -5 and then you mark a half.
Yep, I'm going to mark both of them on the same number line.
Gotcha.
Does everybody have that?
Yeah.
Okay. So I'm going to put -5. This isn't really to scale, but just mark it. So now you've separated your number line into 3 sections. And we've got to figure out what's happening in each section. So let's first look at what happens if we are smaller than -5 in both. So in 2x minus 1,
Negative.
if you're smaller than -5, you would be,
Negative.
yep, you're negative. I'm just going to write that off to the side. And in the second one, if you're smaller than -5, you would be also negative. And you're multiplying the result together. What's a negative times a negative? It's a positive. Okay, let's check the next section. Between -5 and 1/2. Okay. What if you are between -5 and 1/2 in the first one?
Like -3.
Yep, you could be in. Yep, you're still in the negative section. Okay, -5 might be right there.
Still positive.
Well, that's negative, right?
Yeah, but isn't it a negative times negative?
So that part's negative. Let's just start with that. Now, what if you're between -5 and 1/2 in the second one? Yeah, half might be over here somewhere. So between -5 and 1/2, now you're getting into the positive section.
Negative.
So the first one is negative, the second one is positive. What's the product? Negative. Okay, let's do it again. Now we're going to look at bigger than 1/2. Okay. I'm just going to erase what we had before because we don't really need that anymore. Okay, in the first one, if you are bigger than 1/2, what kind of number?
Positive.
And then in the second one, bigger than 1/2, another positive. And what's a positive times a positive? Positive. So hopefully you notice what usually ends up happening is it alternates. So once you figure out one of them, it just alternates. Positive, negative, or negative, positive, negative, positive. But it's always good to check the first 2 sections just to make sure, but I wanted to do all 3. Okay, and now we use that to determine our answer. This problem wants to know where we are greater than 0. Is that positive or negative? Positive. Where we are greater than 0 is positive. Where are you positive? Here and here. So just describe that interval. So we can be from -5. How low does that interval go? Negative infinity. It just keeps going. Right? So you can pick anything from -5, negative infinity, up to -5. We have to see if we should include it. Can we equal 0? No, we have to be strictly greater than 0. If you include -5 with a bracket, you would equal 0. Okay, so you don't want that. So pick anything from negative infinity to -5, or how would you describe that second interval where you're positive?
Can I see 1/2?
Yeah,
There's positive infinity.
1/2. to infinity. So you can pick any number that's in those two intervals, and the result will always come out positive. Now, if they said to you, where does this come out less than 0? You do exactly the same steps. The only difference is in the end, you would write the middle interval. That's where it comes out less than 0, between -5 and 1/2, not including either one. Okay, so whether they ask for greater than 0 or less than 0, it's exactly the same process. Okay, any questions on that one? Okay, so again, for this to work, you have to have a factorable problem. So I will always give you one that can factor, or I'll just factor it for you like this one. Okay, let's mark our roots. Colin, what would you plug in for x to make that first factor 0? 0, yeah. And what would happen if you plug in numbers smaller than 0 for x? What would the result be?
You'd have everything going backwards because everything would multiply and be negatives.
So it would be negative. Yeah, so it would be negative. What if you plug in numbers bigger than 0? It would come out positive. Okay, let's check x plus 3. Hannah, what would be the root or the 0 for x plus 3? -3. Again, these number lines are not to scale. Don't compare this one to the one above it. They're 3 separate number lines. And then if you plug in a number smaller than -3, what would the result be just right there? A negative. And what if you plug in a number bigger than -3? Positive. Josh, my last one, what's the root for x minus 1?
1.
1? All right. And what if you plug in a number smaller than 1?
It would become negative.
Bigger than 1?
Positive.
Positive. Okay, so now mark -3, 0, and 1, all on the same number line. Again, don't make it to scale. Just space them evenly. That's fine. We don't care about that. So -3, 0, 1. How many sections do we have there? 4, but technically once you find the first one, it's just going to alternate after that. So let's check less than -3. Okay, in the top factor, x, if you are less than -3, what kind of number would you get?
Negative.
Yep, you'd get negative. How about in the second one? Less than -3?
Negative.
Negative again. And in the bottom one, less than -3?
Negative.
Negative. -3 would be over here somewhere. Okay, it'd be in the negative section. So it would be a negative. And what's the result if you multiply that together?
Negative.
Negative times negative times negative is a negative. Now, what should the next section be?
Positive.
Positive. We'll check that. But then after that, we'll just go with the pattern. All right, so let's check between -3 and 0. Mike, what do I get if I'm between -3 and 0 in the first factor? -3 and 0. What do you get? Negative, yep. So you're in the negative section. What about between -3 and 0 in the second one?
Positive.
Yeah, now you're in the positive. -3 to 0 is positive. And what about between -3 and 0 in the third one?
Negative.
That's a negative again. What's a negative times a positive times a negative?
Negative. And then positive.
Positive. Okay, so I'm not going to go through and check the rest. It's just going to alternate. Negative, positive. And now the answer is going to be 2 of those intervals. We have to go back and see, is it less than 0 or greater than 0? Okay, so this is greater than or equal to 0. So that would be in here and there. any x values in those two regions will come out greater than or equal to 0. All right, so how would you describe that first interval? How about Andrew? The first positive interval? Yeah, the one that I circled, sorry. Well, what two numbers is it between?
-3 and 0.
Yeah, -3 to 0. Now, do you include the -3 and 0, or do you not include them?
So,
You do,
okay.
okay, because it's equal to. Okay, you could equal 0, so we do include it. So is that a bracket since we include it, or a parenthesis? It's a bracket. Or there's one other place we have answers to. Can anyone give me the second positive interval? Gabby? How would you, well, that interval is from what to what? That
0 to 1.
not the negative. We're just going the circled ones are the answers. So forget about these. So the second positive interval is from what to what?
1 to 2.
Past 2. There's no other mark after the 1, so that means it. You can help her out. Where does that second positive interval stop? Infinity. It's just this interval on the number line. Remember this, I didn't draw it, but there's arrows on the ends of these number lines. So that second interval goes on forever. So it's 1 to infinity. Should I include 1 or not include it? Casey?
Include because it's less than 2.
Because we had the equal to symbol. Yep. Never include infinity because you can't reach it. Okay? So any questions on that one? All right, so that's that. Now, if you did one with division, how did the rules for multiplication with positives and negatives compare to the rules for division with positive and negatives? So if you multiply a positive times a positive, you get a positive. What if you divide a positive by a positive? Positive. So it's the same rules. Right? If you divide a positive by a negative, you get a negative. If you multiply a positive times a negative, you get a negative. So if you were to do a division problem, I'm going to hold off on doing it, but all the rules are the same. Make your number line, find your roots, and then do exactly the same thing. This problem wouldn't be very much different than this problem. You would solve each problem pretty much exactly the same way. What's the only thing you have to be careful about in a division problem now that you don't have to be careful about in a multiplication? Yep. Right, you can't equal 0. So even though it says here you're allowed to equal 0, when you write your interval, don't include any number in that interval that would cause you to divide by 0. Okay? That's the part sometimes people lose like a point on. All right? So the root here would be negative 2.5. You cannot include negative 2.5 in any interval, because if you do, you will divide by 0. Okay? That's the only thing you've got to be careful about with division. Okay? Other than that, I think the problem we just did was actually harder because it had 3 factors. This one only has 2. One in the top, one in the bottom. All right, so if you can't factor it, you can't use a sign chart. Okay, so let's do one on the calculator. Okay, you don't have to write that all down on the top. Because if you can't factor it, I'm going to say on the homework or on the test, use a graphical approach to solve. Okay, so if you can't factor it, you've got to use a graphing calculator, and the directions will tell you that anyway. So let's type that in. And really, we're not going to do anything you haven't done before. We're just going to look for a couple intersection points. So we have x cubed minus 2x squared minus 5x plus 7. And then for y2, you're going to put in 2x plus 1. 2x plus 1. Okay, so I did the x cubed in blue. I did the 2x minus 1 in red. I'm looking for where the blue is above the red, or equal. So let's do zoom 6. And keep in mind what I just said. We're looking for where the blue is above the red. Okay, so let's look at that picture. Make it a little bigger. Okay, if you look at the graph, how many sections is the blue graph above the red?
3.
Yeah, I think just 2. I would say in here, the blue graph is above the red. So you need to find those 2. And then I would say from here on, that's just going to keep going. Those are the sections where the blue graph is above the red. Any questions on how you would find the intersection points? Okay, so let's just call this intersection point A. Let's call that B, and let's call that C. So we don't have to go through on the calculator and find them all. How would you write the interval between A and B, keeping in mind that symbol? About Mina? Do you know how you would write that interval?
No.
Can you help her out? How about Brandon? Can you help her out? Do you know what I'm talking about?
Vaguely. I have an understanding, but I'm not.
So we're looking for where the blue graph, which is this one, okay, is above, well, I don't want to underline it in red because that'll look confusing. But we're looking for where the graph on the left is above or equal to the graph on the right. The graph on the left is the blue one. The graph on the right is the red one. So we agreed, I think, that between here and here, the blue graph is above the red one. And then from here, going on forever. So first step would be to find A, B, and C, okay, those intersection points. And then we have to describe between that value and that value. That's where the blue graph is above the red. So I'm just calling it A and B, but how would you write that interval?
Wouldn't it be like -2 is...
Well, use A and B, because we don't know. It might not be
Alright,
-2.
Okay, so it'd be like,
It might be, but
yeah.
I'm not sure.
So it would be A is less than or equal to, or no, is that wrong?
Let's do it as an interval. Yeah, do it as an interval.
As an interval?
So you use the comma, and then brackets or parentheses.
Oh, okay, alright. So it'd be like the, would it be the A to B and a bracket around A and B?
Yep.
Yeah, okay. Oh, okay. Yeah.
So between A and B, and you
Yeah.
can include it because it said equal to.
And then like it would be C
Yep.
to infinity with the bracket, and then or the parentheses around infinity.
Perfect. Exactly. That's exactly what we're looking for. Yep. So the way you describe that first interval is between A and B with brackets. C to infinity, you always use a parenthesis on infinity. Now you would have to use your graphing calculator and find A, B, and C. And when you find the intersection, just to make sure this is clear, are you looking at the x value or the y value? X. right? The variable is x. So the intersection point is going to have a y value. Maybe the first one is -3 or so. But I don't care about the y value. All we care about is the variable in the problem, the x value. Okay. So definitely not one you could do by hand with a sign chart. You have to use a calculator for that. There's no other way. Yeah?
On the test, are you going to give us like more than the other? Or like, on the test, is it like, it's calculated for all of them? Or is it only going to be like,
You'll have access to a calculator for every problem.
yeah. But I mean like, are there going to be the ones where you don't need them versus the more you need them more? Or?
There'll probably be an even mixture. There'll be some where you have to graph, and then there'll be some where I just say solve with algebra. Or there might be some where I just say solve. And then if I don't say how to do it, you could do it either way. In fact, I know there's at least one that just says solve. And it's a quadratic. So you could pick a sign chart or graphical. All right, so the last thing we'll look at, start to look at, we actually look at through the entire chapter, is polynomial functions. So the idea of a polynomial, these are usually all filled in with numbers, but what I'm trying to show you is you start with your highest exponent, maybe that's like an x cubed, and then your next term would be x squared, would be the next lowest exponent. Then maybe 3x, and then finally plus 5. So when you write out, something like this, we just write it from the highest exponent, and then the number on the exponent goes down by 1 each time. And the a sub whatever it is, that's just the number in front. Okay, so like in my problem, the first one here was a 3. Okay. Then I did a -2. Then I did a 1, even though I didn't write it. And then I did a -5. So those are just coefficients. Okay, but that, in general, is what a polynomial always looks like. It doesn't have to have every term from the highest to the lowest. Okay, you could have something like this. There's no 4th degree term, there's no cube term, there's no squared term. Just a 5th term and a constant. Nothing else in there. Okay, that's fine too. But what's important is the exponent has to be a non-negative integer. So in a polynomial, exponents can never be fractions. They can never be decimals. They can never be negative numbers. They have to be non-negative integers. Okay, and all the numbers that you put in front have to be real numbers. So these, you can't use imaginary numbers. So all coefficients must be real numbers. Okay, so no imaginaries. Okay, if the highest degree term doesn't have a coefficient of 0, so if you had something like this, the highest degree term is right there. Okay, that's the coefficient of it. It's a 3. It's not equal to 0. If that's the case, then the exponent is called the degree. Okay, so this is a degree 5 polynomial. It's the highest exponent. But if I did something like this, if I made that a 0, that's not a degree 5 polynomial anymore. What is it now?
Degree 2.
It's a degree 2. If you're going to put in
0.
Yeah, if you're going to put in a 0, it's like that doesn't even really exist. So the highest degree term now is a 2. So if they put something in with a 0, that's kind of tricky. But it's usually that term that's in front, the first term. Okay, that's the degree. Some degrees have special names. Okay, like a degree 1 is linear, because if you draw it, it's a line. Degree 2, that's a quadratic. Degree 3 is a cubic. Degree 4 would be a quartic. But much beyond that, we just say we have a polynomial of degree 12. Okay, there's no special names. Okay, the domain. One thing that's nice about polynomials is the domain is all real numbers for every single problem. Because with a polynomial, like that one, all you're doing is raising numbers to powers. And you can raise any number you want to any power all the time. And maybe you're multiplying by a 4 or then subtracting a 5. There's no division. So you're never going to have a divide by 0 with these. There's also no square roots. So you're never going to take the square root of a negative. So the two things that can mess up your domain are never in polynomials. There's no division. There's no square roots. So domain is always all real numbers. The range depends. Okay? But the domain is all real numbers. Cubic functions, okay, where the highest exponent is a 3, generally look something like that. So a couple things. The highest exponent tells you how many times you could cross the x-axis. So for a cubic, it could cross up to 3 times. Okay. It could also cross just twice. Or maybe it just crosses once. Okay, so 1, 2, 3. Also, the exponent, if you subtract 1 from it, tells you how many times the graph can turn. So a cubic can turn 2 times. Here it's going up, it turns down. That's 1. It's going down, it turns back up. There's 2. So that exponent really tells you a lot.
So does it just really mean it has 3 intercepts?
It could have 3. It doesn't have to.
It doesn't have to have 3?
But it could have...
It doesn't have to be on the axis.
Yes, it could have up to 3. It could also have 2. It could also have 1. But a cubic could never have none because it goes forever. So if it goes down forever and it goes up forever, it's going to cross 0 somewhere. How many times could a 4th degree polynomial cross the x-axis?
3.
More than 3. 4. Okay, a fourth degree could cross the x-axis 4 times. It could cross 3 times, 2 times, 1 time. Oh, oops. Lost my line. Could cross 1 time, or it could cross 0. Okay. Because this type of function has a lowest value, and it doesn't go any lower. Or you could flip it over, think of like a parabola, flipped over. It has a highest value, and it doesn't go any higher. So it is possible that these types of graphs never cross the x-axis. Okay, you don't really need the formula. All you really need to understand is that it can cross 4 times. It can turn 3. It's going down. It turns to up. It's 1. Up, turns back to down. There's 2. Down, back to up. There's your 3rd one. And notice I'm saying up to. Doesn't have to. Okay? A 4th degree polynomial can also look just like this. Kind of looks like a parabola, but it's a little flatter on the bottom. All right, so let's look at this one. That's a polynomial. What's the domain of that polynomial? All real numbers. You shouldn't even think about it. You can take any number you want and cube it, and then multiply it by 5. There's no dividing. There's no square roots. So the domain, all reals. If you want to write negative infinity, comma infinity, you could do that too. Okay, but the range. It's a fourth degree polynomial. Is this the kind of polynomial that's going to go up forever and down forever? No, it's a W shape, or it could be a W shape. So it's going to go in one direction forever, but not the other. So plus 5x cubed plus 2x squared minus 8x, what is it? Plus 1. All right, let's do zoom 6. We'll start there and see what it looks like. Okay, so I think you can kind of see the W shape, but to actually see how low it goes, I need to set my Y max a little lower. Y min, sorry. Probably -20 would be enough. So, does this graph go up forever, down forever, or both?
Just up forever.
Just up forever. So what happens is it bottoms out right here. So anything from that value up is your range. Okay, so how do I find that lowest value? What is that called? That's the
Vertex.
Well, what's the lowest value called for something?
Minimum.
Yeah, a minimum. I was just trying to word it the way it is on here. So it's under minimum. Okay, you've got to pick a value to the left, pick a value to the right. Now it's going to look in between those dotted lines for the minimum. You got to hit enter one more time for the guess. And it tells me the minimum is -11.95. That's what it says right there. So I will hit every value on the y-axis from that up. Okay, it doesn't go any lower than -11.95. Any question on that one? Yeah.
Every time I hit the enter the third time, it says error.
All right, let me take a look at it after. Just if you can show me, keep that problem on your calculator, and we'll see what's going on.
Oh wait, I just got it.
Oh, you got it?
Yep.
Okay.
Thank you.
Oh, I didn't do much. Fifth degree polynomials, I'm not going to get into right now. But what I want to talk about in that picture is what's called a local max and a local min. Okay. When you have a local maximum or minimum, I'm not saying that this is the highest value ever. I am saying that it's higher than everything around it. Think of it as like a hill in the middle of like a field of mountains. There might be points that are higher, but this point is the highest value around it. Okay. That value that I just circled, that's a local minimum. What that means is it is lower than everything else around it. So if you wanted to just summarize that, a local maximum is a point higher than everything around it. Okay. So if you had a graph like this, that's a local max, that's a local max, that's a local max. It's higher than everything else around it. Okay. A local min is a point that's lower than everything else around it. That's a local min. That's a local min. Okay, so together, all your local maxes and mins, those are called your local extrema. So if you see a question that says, find the local extrema for the following graph, what they're asking for is the local maxes and mins. Okay, so any questions on that? Okay, so let's Try a problem. So I'm going to use the same problem, and I want to find there's going to be a local min and there's going to be a local max. Okay, and it's x cubed minus 4x. So x cubed minus 4x. So the question asks me to find the local minimum and where it occurs. Okay, so let's start with the minimum. Second calc. Minimum. Okay, pick a point left. Right? Yes. Okay. Let me make it bigger. Where is the minimum? At what value does the minimum occur at? That's what the minimum is. 1.15 is where it occurs. You would plug in 1.15 for x, and you would get -3 for y. So the minimum is -3.08. And it occurs at, or it occurs, I'll write it like this, when x equals 1.15. So the y value is what the minimum is. The x value is where it occurs. Any difference, any question on the difference between what it is and when it occurs? So what it is, y value. Where it occurs, x value. And I think, I'm not going to go through and do it right now, but the maximum, I think it's symmetrical. I think it's -1.15 for x and +3.08 for y. I think it's like a mirror image. Okay, but to find the local max, you would do the same thing. Okay, so when you look at a local max or min, okay, think about like being on a roller coaster. Right before the local max, what are you doing? Running out of track. Going up.
Elevated.
Yep, I'm going up, right? Elevating, going up. And then you hit a local max, and then what happens? You're going down. So anywhere that you have a local max, you go from increasing to decreasing. Now, what about a local min? Right before a local min, what are you doing?
Decreasing.
You're decreasing.
Then you're increasing.
And then you're increasing. Okay? And that's the point of the last thing. So, this particular function, it asks you, where is it increasing? It's increasing between B and C. Where is it decreasing? Well, yeah, it's decreasing from A to B. And it's also increasing from C to D. So now it says, what happens as you go from increasing to decreasing? What did we just say happens as you go from increasing to decreasing? You get a maximum. Anytime you go increase to decrease, you get a max. Okay? And what happens if you flip that around? What if you go from decreasing to increasing? You get a minimum. Okay, so you might see a question on the homework that says determine where the function is increasing. Okay, that's what we just did right there. Or where is the function decreasing? They won't give you A, B, C, and D. You'll have actual numbers. Okay? Okay, Any questions on that? All right. So there's homework for tonight. Okay, a lot of these are graphing questions or questions where you just have to write like one answer, increase, decrease, things like that. Okay, so we'll take a look at that first thing tomorrow, and then tomorrow we'll finish up everything, and I'll be after school tomorrow in case anybody needs to review for the test on Friday.